Hello, hello, and welcome to Dial in Verilog tutorial 11. Today I'm going to make dual port asynchronous read write RAM, and this is the programming for dual port asynchronous read write RAM, in which there are two addresses, address underscore 0 and address underscore 1, two datas, two chip select, two write enable, and two output enable. Fine, these are different parameters. Now in for two port input port, there are address, chip select, read write enable, output enable, where address is of 8 bit and address 2 is again 8 bit. Now there are two total in out ports, data underscore 0 and data underscore 1, and it is also 8 bit. And there are three internal resistors that are data underscore 0 underscore out, data underscore 1 underscore out, and third, that is data weight, means 8 bit memory, and their address is 0 to 8. Now in a memory write block, whenever this type of condition occurs, whenever there is event in any of these parameters, address 0, cs 0, we 0, data 0, address 1, cs 1, we 1, data 1, in this type of events, this loop is going to execute, in which if there is chip select is 0 and write enable is 0, sorry, if chip select is 1 and write enable is 1 for 0th port, at that time whatever data is there, that will store in the memory at this specified location. And whenever there is second type of condition, means a cs1 is equal to 1 and we1 is equal to 1, and this is not happen at that time, data 1 will store in the memory specified by address underscore 1. Now in the read operation, wherever there is address cs0, we1 and oe1 event occur, at that time, if cs0 is equal to 1, we underscore is equal to 0, and we underscore 0 is equal to 1, at that time whatever data at this specified address, it will store in data underscore 0 underscore out, otherwise 0. And simultaneously memory read from second port, that is whenever cs1 is equal to 1, we underscore 1 is equal to 0, and oe underscore 1 is equal to 1, at that time whatever data stored in this specific address, it will store in data underscore 1 underscore out, otherwise it is 0. So this is all about the programming. Let's synthesize this, and then we will check this programming in on test bench. So save this and synthesize this. Okay, fine. So now synthesization is successful. Now we will check the test bench of this. So simulate visual model. Okay, so these are the different waveform of RAM, in which first we have to set address 0, of course constant, and set address underscore 0 to first location, and then chip select is equal to 1. Okay, then chip select is equal to write enable is equal to 1. Okay, output enable is equal to 0. Okay, then address underscore 2, let's give it to second location. Fine. Now cs is equal to constant 1, and w write enable is equal to 1. Output enable is equal to 0. Now take the data like this: 10101010, and second data as a 4041. Okay, so now let's run this. So you can see this data underscore 0 will store in the first location, this address location, and to write another data, that is data underscore 0, the this data is written here, and to write this data on this location, we have to enable this write enable to 0. Okay, and then run. So this second data will store here. Fine. Now to read these two data, read we have to first output enable this. So now this this data will store in data underscore 0 underscore out. Fine. Now to read this data on data underscore 1 underscore out, we have to just disable this and enable this one. Now here this data will read by this port 000111. So in this way, this dual dual input asynchronous RAM will work.